quantity of aluminium is deposited when a current of 10 ampere is passed through a solution of aluminium salt for 1930 seconds. Given that the atomic mass of aluminium is 27, 1 Faraday is equivalent to 96500 coulomb per mole. Option A, 0.2 gram. Option B, 1.8 grams. Option C, 5.4 grams. And option D, 14.2 grams. So this is electrolysis in chemistry. To solve this question, we have to apply the Faraday's first law and second law of electrolysis. So let's bring out the parameters given below. For the question, we have the current of 10 ampere. Current I is equal to 10 ampere, and that's not equal to the time given in 1930 seconds. So time t is equal to 1930 seconds. According to Faraday's first law of electrolysis, which states that the mass of a substance liberated or deposited at an electrode during an electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. We have the formula as Q, which represents charge, is equal to current times time. So let's substitute the value. Q, charge, is equal to current is given as 10 amperes times time is given as 1930 seconds. So we are going to obtain 1930 coulomb. So that's the first thing we must determine. Now from the question we have what quantity of aluminium is deposited. To determine the quantity of aluminium deposited, we have to apply the Faraday's second law of electrolysis, which states that when the same quantity of electricity is passed through different electrolytes connected in series, the relative number of mole of the element liberated or deposited during an electrolysis is inversely proportional to the charges of the ion of each of these elements respectively. So from the law, we have quantity of electricity Q1 over M1 is equal to Q2 over M1 M2. So according to electrolysis or acidified in water using platinum electrode or graphite, let us determine the ionic equation for the aluminium salt given. Aluminium salt A3 plus 3 electrons would yield aluminium solid. So the charge for aluminium is +3. At this point, we are going to determine the quantity of electricity, which is Q1, using this charge. So Q1 is, now take note of these parameters. Q1 is the quantity of electricity from the ionic equation given, whereas Q2 is this quantity given from the question, quantity of electricity from the equation given. M1 is the atomic mass of the element present, and whereas M2 is the expected mass of the element from the question. So Q1 is equal to the quantity of electricity from the ionic equation, and from the ionic equation, aluminium is +3, using the electrolysis classified in water, graphite or platinum electrode. So we have 3 times 1 Faraday. 1 Faraday is equal to 96500 coulomb per mole. So 96500. This will be 28950. So since Q1 is given as 28950 coulomb, then Q2 is equals IT, and it was given to us as 19300 coulomb, where M1 is equal to the atomic mass of aluminium, which is 27.0, and M2 is the expected mass of the element in the question. So we are going to make M2 the subject of the formula from here. So M2 is equal to, making M2 the subject, M2 equals Q2 times M1. Q2 times M1 divided by Q1. So let's substitute the values. At this point, we are going to have Q2, and Q2 is equal to 19300 times M1, and M1 on the board is 27 divided by Q1, and Q1 is given as 289,500. So if you add this up, we are going to obtain multiply this by this, we are going to obtain 521,100 divided by 289,500. So this divided by this, M2 is equal to 1.8 grams. So the correct answer is 1.8 grams.